Most of us have seen pictures of the solar system where the planets are next to each other. It gives us an impression that they are not very far apart from each other. Although it is necessary to ignore the actual scale of distances to accommodate all the planets within a sheet of paper, it often misleads us. We often do not appreciate the vast distances among the celestial bodies. Today, I am going to Ruislip Lido, a small lake just outside of London. There is something special here, walking with the planets. There is a walking trail around the lake, and on this trail, there are little landmarks for the worlds in the solar system. These landmarks are placed according to their relative distance to each other, according to their real distance. Therefore, when you walk down the trail, you get an idea of the actual scale of the solar system. We start our journey from the Sun, the center of our solar system, and the only star in the neighborhood of few light years. The Sun is by far the most massive object in the solar system. It consists of 99.86% of all the masses of the solar system, which is a lot, more than 300,000 times more massive than the planet Earth. The Sun's core is so hot that it burns hydrogen into helium and produces all the energy of the solar system, a vast amount of light and heat. We take a stroll for nearly 60 million kilometers from the Sun and we reach Mercury, the first planet of our solar system. Mercury has no atmosphere, as any gas it might have trapped has long gone, blasted away by the solar winds. Then we find Venus, 100 million kilometers from the Sun. Venus is roughly the same size of Earth and is often referred as Earth's sister planet. We move ahead, and at 150 million kilometers from the Sun, we find our home, the Earth, our very own blue planet, only known world in the entire universe to harbor life. The next planet is also not very far. We can see Mars, the red planet, at 220 million kilometers from the Sun. Mars is smaller compared to Earth and Venus. We have some of our robots roaming around on this planet, and maybe soon we will have human presence here too. These four planets we just visited until now are also known as inner solar system. These four are rocky planets formed by the leftover heavier elements after the formation of the Sun. We now see the largest asteroid in the asteroid belt, Ceres. Most asteroids are irregular in shape because they do not have enough gravity to pull themselves into a sphere. But Ceres is large enough to become spherical in shape. This is classified as a dwarf planet, like other popular dwarf planet, Pluto. Between Mars and Jupiter, there are a lot of asteroids, small worlds which could never form into planet, mostly because of the gravitational influence from Jupiter, which scattered the asteroids and never allowed them to combine into a single large body. From popular culture, many of us think that asteroid belt is a very crowded place with rocks scattered everywhere, and spaceships need special maneuver to avoid collision with the boulders. But that is far from the truth. Space is immensely large. Asteroids are far away from each other. If we could stand one of the asteroids, in most likely scenario, we would not see another asteroid in the horizon because they are far away from each other. Space is space. There is mostly nothing in it. We have traveled quite some distance now, and we are nearing the godfather of all planets in the solar system, the mighty Jupiter, 780 million kilometers away, more than 5 times the distance between the Sun and the Earth. Jupiter is massive, 318 times more massive than the Earth. If we combine all the masses of the other planets in the solar system, Jupiter would still be 2.5 times more massive than the combined mass. Jupiter dominates the solar system with its gravity. There are many asteroids and dwarf planets orbit the Sun in sync with Jupiter's orbital period. The movement of these bodies are determined by the movement of Jupiter. Jupiter keeps these asteroids and dwarf planets in order, like a shepherd. We have utilized Jupiter's gravity to speed up our spaceships we have sent to deep space. We calculated the trajectories of the spaceships in a way so that Jupiter's gravity will work on them like a slingshot, increasing the speed of the ships significantly, allowing the spaceships to travel vast distances quickly. Here I got slingshot by Jupiter too. Instead of walking through the trail, I have changed my trajectory over this beach, shortening my walk towards the next planet by some degree. Jupiter is so large, it causes the Sun to wobble. In fact, the center of gravity between the Sun and Jupiter is located outside of the Sun, which makes the Sun to rotate this point. If an alien would observe the Sun through their telescope from their world, they would be able to confirm Jupiter's existence from this wobbling motion of the Sun. We know this because this is the same technique we use here in Earth to detect planets around other stars in our galaxy. Jupiter is one of the brightest objects in the night sky, so humans have seen Jupiter for a long time with their naked eye. At this time, the general belief was that the Earth is the center of the universe. All the other stars, including the Sun, the Moon, and the planets, rotate around the stationary Earth. In late 1609, Galileo Galilei started observing Jupiter. With the aid of his telescope, he found some smaller worlds around Jupiter: Io, Europa, Ganymede, and Callisto. He observed them for several months and concluded that these four objects actually go around Jupiter. They are the moons of Jupiter. Jupiter has its own system. So not everything in the universe rotates around the Earth. Worlds in the sky can rotate around each other too. This was a shocking discovery at that time. We have now traveled more than 1 billion kilometers from the Sun. In fact, we have traveled 1.42 billion kilometers, 9.5 times the distance between Earth and the Sun. And here comes the second largest planet of the solar system, the Saturn. Saturn stands out among the planets for its gorgeous ring system. The rings are made of mostly ice particles and reflect light. That's why the rings are so bright. Saturn is 95 times more massive than the Earth. Although it is very heavy, Saturn has the lowest density among the planets. In fact, Saturn's density is lower than water. That's why there is a popular saying, if we could find a large enough pool, Saturn would float on it. But technically, that would not be the case, because that much water would collapse onto itself due to its gravity into a giant icy planet, and it would blast into Saturn if it ever came to play with it in the pool. Jupiter and Saturn are known as gas giants. These two planets are made of mostly hydrogen and helium, the same materials of the Sun. After Sun formed and gobbled up the gases near the center of the protoplanetary disk, Jupiter and then Saturn formed from the leftover hydrogen and helium in the outer solar system. Saturn has a huge role in stabilizing the solar system. Most of the exoplanets we have discovered so far in this galaxy, we have found that a lot of Jupiter-like giant planets rotate their stars very closely. It is believed that Jupiter also started falling towards the Sun after it formed. Jupiter started its journey towards the inner solar system, destabilizing the asteroid belt and starving Mars, not allowing it to grow as big as the Earth or Venus. It would be catastrophic for Earth too if Jupiter continued its inward journey. But then the second giant formed, the Saturn. Saturn's gravitational tug prevented Jupiter from falling inwards. The stability of the solar system was obtained by the tug of war between the giants. Up to Saturn, the first 5 planets, excluding the Earth, are visible in the night sky with naked eye. So humans knew them from ancient times. We have named our 5 days of weeks on these 5 planets. We have named the remaining 2 days based on the Sun and the Moon. Our next planet, the Uranus, was discovered with the aid of telescope. 2.87 billion kilometers from the Sun, more than 19 times the distance between the Sun and Earth. A pale blue ball, 14 times more massive than Earth, hanging in the darkness of space. Uranus is the only planet in the solar system that rotates sideways. It looks like rolling on its side on its 84 years long journey around the Sun. Uranus and the next planet, Neptune, are also known as ice giants. They are composed mostly of ammonia, methane, and water ice, two of the coldest worlds in our solar system. Uranus's surface is mostly featureless. On the other hand, Neptune has a very violent atmosphere. We have recorded the fastest wind speed in the solar system in Neptune, a storm nearly 2000 km per hour. Neptune's core radiates internal heat. In fact, Neptune radiates out more than 2.5 times more heat than it receives from a very distant sun. It is believed that this internal heat powers the stormy weather in Neptune. As we are walking to find the last planet of the solar system, Neptune, let us appreciate the vast scale of the solar system. At the beginning of our journey, we were meeting new planets every few steps. The four inner planets are located comparatively close to each other. From the Sun, 60 million kilometers to Mercury, 100 million kilometers to Venus, 150 million kilometers to Earth, and 220 million kilometers to Mars. But here in the outer solar system, the distances are immense. Jupiter lies 780 million kilometers away from the Sun, Saturn at 1.42 billion kilometers, 2.87 billion kilometers for Uranus, and Neptune. It is on average 4.5 billion kilometers from the Sun, more than 30 times more distant compared to Earth. Here we meet with a comet, probably thrown away from the Kuiper belt, which lays beyond Neptune. Comets can take few years to several thousand years to complete their journey around the Sun. Even at this large distance, gravity dominates. Neptune is captured into its orbit by the gravity of the Sun. In fact, the gravity of the planets have impact on each other too from vast distances. After the discovery of Uranus, upon close inspection, it was evident to the scientists that the orbital period of the planets does not add up. It looks like there is something else out there impacting the movements of the planet. In fact, the position of Neptune was calculated even before its discovery, based on the orbits of the other planets. Then we found the eighth planet of the solar system, Neptune, where it was predicted based on our calculation. And here we meet Neptune, 17 times more massive than the Earth, a blue marble hanging at 4.5 billion kilometers away from Sun. The poster of Neptune is missing though, it should have been here. The journey does not end here. The solar system stretches beyond Neptune. There are Kuiper belt, many dwarf planets, and last but not least, Oort cloud out there. The Sun's gravity is dominant up to 2 light years from this point, so effectively, solar system's boundary is far, far away from here. There we see in the distance, there are other stars out there. We can see them from afar, but we are still within our solar system.